Hello and welcome everyone. My name is Mounes and today I will be talking about Ternary search algorithm, which was my selected algorithm for the final project of the Introduction to Procedural Programming course. So let's start off by defining this algorithm. So what's Ternary search? In fact, Ternary search is a divide and conquer searching strategy for determining the position of a given target in a sorted array. It works just similar to binary search, where we divide the array into two different parts. However, here in this algorithm, we divide the array into three different parts, uh, and we reject two of the parts on each iteration by trying to identify where our target is, in which part it is. Um, Another usage for this algorithm is for determining the minimum or the maximum of a unimodal function or a unimodal sequence, where the numbers start by strictly increasing till reaching a maximum point and then decreasing. Um, with that being said, I think now we are ready to take a look at the C code implementation. So here, after defining our functions in the main method, here we're generating a random target, and here for giving the data a different sizes, I'm using this by 10. I'm starting the data size by 10 and then multiplying it by 10 on each iteration. So it's 10, 100, 1000, and the upper limit is 100 million. And then I'm calling the function, and I'm storing the number of iterations made by the algorithm till it finds a result in this number of iterations array, which in its turn it's going to be used in the plot function, where I would show the results, which would give us a clear idea about the time complexity, of course. So let's take a look at this Ternary search function. Here, while the start index is less than the end index, less or equal to the end index, we are repeating these steps. First, we identify our middle points on each iteration. Then we begin by comparing the element and the middle one with our target. If they are the same, then we return middle one. If they are not, we compare it to the element and the middle two. If they are the same, we return middle two. If they are not, we then start our process of identifying where our target is, in which part it is. We do that by checking if the target is less than the element at the middle one. Then we know that we recur to the first part and we ignore the other parts. If it's not, we check if the target is bigger than the element and the middle two. If yes, then we recur to the third part, the last part, and we reject the first two parts. And if not, then there's no chance, but the target is in the middle. And we do that till this condition is not valid anymore, and if it comes out of this while loop without returning any value to the main loop, then we know that the target is not in the array actually, and we return to the main function. And in this plot, I'm just plotting the data that would give us a clear idea about the time complexity, which should be logarithm base 3 of n, because we're reducing the size of the original array to the third. With that being said, I think we should now try to run the program. Let's do that. Here we can compare these results to the expected ones actually. So when the data size is 10, it should be it found it in 3 iterations. When it's when it's 100, 4, when it's 1000, 6, and so on. Yeah, we can observe that sometimes it finds the target with less iterations, and sometimes it needs more iterations to find it. Uh, um, and I think that was it. Thank you very much for watching, and goodbye.